Hi everyone. Today we'll be discussing the LeetCode problem of the day, design movie rental system. In this question, you are given n shops from 0 to n minus 1, and you are also given a few set of entries and the parameters of these entries are shop ID, movie ID, and price ID. This indicates that there is a copy of movie ID at a shop I with the price I. And also note that each shop can contain only at most one copy of a particular movie ID. For example, if the entry is 0, 2, and 6, this means that at shop 0, we have a movie with movie ID 2 and the price is 6. After that, we have few queries. The first one is search. In this search, you just have to return the top 5 cheapest shops which have this movie, and also those movies should not be rented at that point. In this search method, you are given a movie ID, and in that movie ID, you just have to return the shop IDs, the top 5 shop IDs which contain this movie. Here, this should be sorted based on the price, and if the price is same, then the tiebreaker will be the shop ID. And suppose for a particular movie ID, we only have 3 entries, only 3 shops containing that movie ID. We will just return 3 in this list. And also, if no shop contains that copy, we'll just return an empty list. Now moving to the next method, rent. In the rent, you are given 2 parameters, shop and movie. So you go to this shop ID and you will just rent the movie with movie ID if it's not already previously rented. As we discussed, there cannot be multiple copies, so there can be at most one copy. If the copy is already rented, then you can't rent it to any other person. And next method is drop. So in the drop, you are also given shop ID and movie ID. So whatever the movie ID you have rented, you will just come and drop it. Also, it is guaranteed that whenever a drop method is called, it is sure that previously a rent method is called for the same shop and movie. Finally, we have a report method. So this report method will check all the rented copies, and from all the rented copies, it will return the top 5 cheapest ones. And here, first check will be on the price. If price is same, the next priority will be given to a smaller shop ID. And even if the shop ID is same, then the priority check will be based on the movie. Whichever has the smaller movie ID will appear on first. Similarly, if less than 5 movies are rented, we'll just return only those movies. And if no movies are rented, just a empty list will be returned. In this, the return type is list of list, because we have to return the shop as well as movie. The difference between the search and report is, in the search, we are given a particular movie and we have to return all the shops. But in this report, we just have to check for all the rented movies and return the shop and movie combinations. Let's just quickly go through the first input to understand the question better. So we have 6 entries, and after storing all these 6 entries, we have few queries. So the first query states that you have to search for the movie 1. So in the search method, the movie ID is 1. So this means you have to find the top 5 cheapest shops containing this movie ID 1. So all the shops containing movie ID 1 is these 3. So out of these 3, we have to return the shop ID in the price sorted order. So this 4 is the cheapest one among these. So shop 1 will be coming on first. After that, we have a type. The price is same. So when the price is same, we will see what the shop ID is. Whatever the shop ID has the least value, that will appear first. And then finally 2. So for the search, the answer is 012. After this, we have a rent from shop 0. We are renting a movie 1. So shop 0, movie 1, we'll just mark it as rent. Again, we have another rent query. We are renting from shop 1 and movie ID 2. So shop 1, movie ID 2, this also we are renting. After that, report. So this report method will check all the rented copies and return it in the sorted order of the cost. So we have two entries. In that, this 5 is the cheapest one. So in the rented, we don't need to return price. We just need to return the shop ID and the movie ID. So the first entry, we will just put shop ID and the movie ID. The second entry is 1 to 7. In that, we will return shop ID and movie ID 0, 1, 1, 2, which is this output. After that, we have another query saying drop the rented copy from shop 1 and movie ID 2. So this is the shop 1 movie ID 2. We rented it. Now we are just dropping it again. After dropping it, we again do the search. So we do the search for movie ID 2. So first we see what all the movie IDs with 2 are present. So this and this. And again, we will just sort it based on the price. So this 6 is the smaller than 7. So first we have shop ID 0 and then we have shop ID 1. So we have 0 and 1. Suppose we haven't done this operation. We haven't dropped it. Then in this query, we will only output this one. We will not output this because currently this copy is rented, so it is not available. So that's the first input. Now let's go over the approach. So first we have entries given in as a 2D integer array, which have shop, movie, and price. So the first step is we can just create an object which will combine all the values together. So we have shop, movie ID, price, and also a boolean rented. So whether the particular movie is rented or not. And we also have a version. So let's see what this version is later. Once the object is created, our first step is we need to handle this search function. So in the search method, you are given a movie ID, and for that movie ID, you just have to return the top 5 cheapest ones. So since we have to return the top 5 cheapest ones, we can think of a priority queue. So for each movie ID, we can maintain a priority queue. For movie ID 1, we can have a priority queue which will have so many elements. For movie ID 3 also, we will maintain a priority queue, and so on. And when you have this search method, and when you're given a movie ID, suppose the movie ID is 3, you go into this this priority queue, and you'll just return the top five elements, top 5 shops. So for storing this, we can use a hash map of priority queue. So the key will be the movie ID, and the value will be just the priority queue, which will just hold the movies. And similarly, for the report, we don't have any specific query that I only want the rented movies of a particular movie ID. So for that report, we can directly take a normal priority queue. So in the normal priority queue, we can just add all the rented items and just return the top 5 items. So let's just see. We have the input, all the 6 entries. So the first entry is 015. Like we discussed, we are separating them based on the movie ID. So this entry will go to the first movie ID, and in the priority queue this gets added, and initially the rented will be false and the version will be 0. So this particular entry will go to the second movie ID and it will be added. This third one will go to this and it will be added here. For this, the movie ID is 1, so it gets added here. For this, movie ID is 2, so it gets added here. And finally, for this entry, movie ID is 1, so it gets added here. Also, I want to take another list of hash map, which will store what movies each shop have. So we have in this input, we have 3 shops. So I have created an array list of size 3. So again, this entry belongs to shop 0. So in the shop 0, I have inserted it. Also, while inserting, I am again sorting it based on the movie ID. So in the shop 0, for the key movie ID 1, I am inserting this one. For this, the shop ID is 0, so I'll go to the 0th index, and the movie ID is 2. So in 2, I will just add this entry. And similarly, shop ID is 0, the movie ID is 3, so key is 3, and the value is this. Similarly for the rest, 1, it goes here. Again, shop ID 1, it goes here. For this, shop ID is 2, and it goes here. We are creating this shop movie map because for any given shop ID and movie ID, we can fetch the particular object, because like we see in the rent and in the drop, we are given shop and movie. So based on shop and movie, we should be able to get the object. So that's why we have created this shop movie map. Now, once we have created this, let's we have created this priority queue map of priority queue. So the search method will be pretty easy. So when you have the query search 1, so what you do is you go to the first key, and in this priority queue you will try to get all the top 5 elements in this priority queue. So the first one will be this, because 4 is the smallest one. So you will output this, and this. So with the first query, your answer will be 1, 0, and 2. Also, while checking, you should also check what is the status of this rented. If it's false, then only you can consider this in your final list. If it's true, that means it is rented, so it's not available. So that's search function. Now let's go to the rent. So in the rent, we have 0 and 1. So what we do is in this shop movie map, it's a list. So we go to the index 0. That is where our shop 0 is. In that, we go to the movie ID 1. So this is movie ID 1. And then we can fetch the object. So the object is 0, 1, 5, false, and version is 0. Now once we have this, we have to rent out this object. So for that, I'll again create a priority queue. This priority queue will just store all the rented values. So I can directly insert this here. But before renting this, the first thing we need to check is what is the rented status of this. So initially it is false. Since it is false, that means it is not rented, so I can rent it. So my first step is I will make the status as true. So 0, 1, this will be true. We have rented it, and then I'll create a new object, and then I'll insert it in the rented map. So it will be 0, 1, 5, true. And here let's also increase the version. So whenever we are renting it, we will increase the version by 1. So the version becomes 1, and I'll add it here. Note that this object and this object is not same. We are creating a new object with the same values, and we are inserting it. So the rent is done. Yeah, since I have updated the value true and 1 here, the same thing will also be reflected here because the object, the both objects are same. So this is true, and the version is 1. Now we have another rent operation, 1, 2. So we go to shop 1, and we go to the movie ID 2, and this is our object. 1, 2, 7, false, 0. So first what we do is we check whether the rented status is false. So it is false, so we can rent it. So we make it true, we increase the version, make it true, increase the version, and then create a copy of this and add it here in the rented priority queue. So we have 1, 2, 7, true, and then version is 1. Also, since we made the changes here, the same thing will also be reflected here. So this will be true, and this will be 1. Till now, we haven't really know what the use of this version is. So it will be useful to avoid the duplicates. So let's see when we do this rent again. Now we have rented these both items. Now we just have to report it. So in the report method, what we do is we check in the reported priority queue, and we just return the top 5 elements. Also, while return the top 5 elements, what we do is we will check the version. We'll check the version of this with the version. So the first entry will be 0, 1, 5, true, and then 1. So this entry belongs to this. So we see that version 1 is and version 1 both are matching. So this is a valid entry. And we also check whether the rented is true or not. So it's true. So we will add it in our answer. Now moving to the next entry. For this as well, we will check what is the version. We'll compare the version number, and both are matching. So this is also a valid entry. So in the report method, you will return both these entries because both are valid. Now after report, we have a drop. So now we'll just understand what the use of the version is. Yeah. So we have a query drop 1, 2. So 1, we go to the index 1 and then movie ID 2. So in movie ID 2, we will get the object. Object is 1, 2, 7, true, and then version ID is 1. Now once we have this object, since we are dropping it, for dropping it, we will change the rented boolean to false, and also we will update the version to true 2. We will increase the version. So that means this will be false and the version will be 2. So if you notice that since in the original object the version is 2, and in this rented priority queue the version is still 1. So that means there's a version mismatch. So based on this, we can know that this is a invalid entry, because this is added when we have rented it, but we are again dropping it. So to make this entry invalid, we are just increasing the version. So currently the version will be 2, but in this rented priority queue the version will not change because this is just a copy. So after dropping it, we have a search query. In search, we have movie 2. So we go to the movie. Also before that, since we are making the changes here, the same thing should also be reflected here. false and the version ID 2. Now when we go to the search, so we go to the second key in this hash map, and from the priority queue we will get all the top 5 elements. Also, while getting the top 5 elements, we will check what is the status of the rented. If it's false, then only we will consider it in our answer. Like I explained, like we discussed in the input, if we hadn't dropped this, the status of this will remain true, so we won't consider this entry. So this search method will only return this one. Yeah. So after the search, we again have a rent. We are renting 1, 2. So we have 1, 2. First we go and fetch where we have this entry. So 1 we check in the first index, and movie ID is 2. So we check in the second key, and this is our object. 1, 2, 7, and then false, and then 2. So we have to rent this. So first step is we will check if the status is false. It's false, so we make it as true. And then we will also increase the version to 3. And then we will add it here as a copy. So we have 1, 2, 7, true. And then the version is 3. And the same thing will be updated here as well. True, and then 3. True, and then 3. We can notice that we have 2 entries which belongs to the same movie, shop 1, movie 2, and price 7. But we can see that the version is different. Now when we call the report method, all these 3 items will be reported, but only this item will be considered, because no. Yeah, let's just see the report method now. Yeah, in the report method, the first object is 0, 1, 5, true, and then 1. So this corresponds to this entry, 0, 1, 5, true, and 1. So here we check this version and this version are matching. So we can say that this entry is true. Now we check the next entry. We have 1, 2, 7, true, and 1. So this object is representing this one, 1, 2, 7, and then true and 3. Here we can see that the original version is 3, but in this entry the version is 1. That means this is an invalid entry, so we won't count this. Now again we have the third entry, which is 1, 2, 7, true, 3. For this we can see that the version 3 and the version 3 are matching. So this is also a correct entry. So in the output we will return only these 2. If we don't have the version check, all these 3 entries will be returned. That means this 1, 2, 1, 2 will be returned twice, and that's not wrong. That's not correct. That's why we use version to invalidate the stale entries. Now let's go over the code. So first we'll be creating a class. Let me just use this. And then shop, movie ID, price, rented, and version. Start shop equal to shop. Movie ID start price equal to price, rented equal to rented, start version equal to version. Yeah, so the class is created. Like as we discussed, first we need a hash map of priority queues. Hash map In this, the key will denote the movie ID and the value will denote a priority queue. Priority queue, and it will contain movies. And we also need a list of hash map. In this, in the list, each index will denote the shop ID, and in that particular row, in the hash map, the key will denote the movie ID, and the value will just denote the movie. Shop movie. Shop movie map. And also finally we have a priority queue movie, which will just store the rented movies. Camel case. Now coming to the initialization, let's first initialize the hash map. And the priority queue rented movies. New also we need a comparator, because we have a certain logic based on how we have to prioritize the movies. Movie B. So for comparing movies in the rented priority queue, we should first check it based on the price. If price is same, based on the shop. If shop is also same, we need to compare based on the movie. So if A dot price is not equal to B dot price, if price is different, then just compare based on that. Integer dot compare A dot price, B dot price. After that, if price is same, then we will check based on the shop ID. If shop is not same, compare based on the shop. If shop is also same, then we will compare it based on the movie ID. So the rented movies is also initialized. Let's also initialize the list. New array list, and the size will be n. It is already given here. I equal to 0, I less than n, I plus plus. Show movie map dot put. Here we are just putting a new hash map, new empty hash map. So we have initialized all our data structures. So let's just iterate on the entries now. For int array entry in entries, let's first create our object movie, new movie. The shop ID will be we get the shop ID from entry 0, movie ID from entry 1, and the price from entry 2. And initially the movie is not rented, so the rented is false and the version is 0. So we have the movie. Let's first insert it in our list. So dot get the shop ID. Shop ID is from entry 0. and in that the movie ID is entry 1, and this is the key, the value is the movie. Now this is done. Let's also insert it in movies. So for the movies, first we have to check whether the movie ID is already present in our movies hash map or not. So if movies dot contains key, entry 1 will give you the movie ID. If it's already present, then movies dot get, so get the priority queue, and in that just add this movie. Now if it's not present, if the key is not present, so we will create a new priority queue. Priority queue movie PQ. Let me just copy this. So for this priority queue, what we have is, first we have to sort it based on the price. If the price is a tie, we just have to sort it based on the shop. So we don't need to do the movie. So directly we can just compare the shop. If price is same, if price is different, compare on the price. If price is same, just compare on the shop. So once the priority queue is created, in the priority queue add this movie, and in the hash map movies dot put entry of 1 comma PQ. So we are done with the initialization. So let's go the search method now. In the search method we have to return a list of shop IDs. So let's just create it. Array list. So once we have created this, we need to get the priority queue based on the movie. So priority queue equal to movies dot get movie. And also there might be a case where this particular movie is not even present in any shop. So in that case, first we need to check if the movies is present or not. If movies dot contains key movie, if it doesn't contain the key, we just return the empty list, which is answer. Else it is present, else we get the priority queue. So once we have the priority queue, let's just iterate and get the top 5 elements. Not iterate, just remove it until we get the top 5 elements. So while answer size is less than 5, so until we get top 5 elements, we just remove it. But there might be a case where we don't have 5 elements, so we also need to check the priority queue is not empty. While answer.size is less than 5 and while priority queue is not empty, movie, we get the current movie doing pq.remove. So once we remove it, we can add it in our answer. In that answer, we just need the shop, current.shop. But before adding it, first we need to check whether this movie is available or not. That means if current.rented equal to false. If it's not rented, then only you can add it. And after that you can return answer. But one thing we can notice is while doing this operation, we are completely removing the 5 elements from the priority queue. So the next time we get the same query, those 5 elements are removed. But while doing the search function, we should not remove the elements. We should just get the top 5 elements. So let's just store all the elements that we removed, and we can just add it back later. Temp equal to new array list. So as I am removing it, I'll just add it back in this temp.add current. So at the end, once everything is done, pq.add all temp. So whatever the elements I removed, I'm again just putting them back in this. So this is not a costly operation because we are only doing it 5 times. So the complexity will be just order of 1 only. So now we are done with the search method. Let's go with the rent. So for the rent, we have shop ID and movie ID. So we can get the movie rent movie equal to for the rent movie, we can get it from this list. Since we have shop, we can first go to that particular shop, and in that shop we can get the movie because it's a list of hash map, so movie is the key. Once we get the movie, what we do is first we check whether that particular movie is already rented or not. If it's already rented, we can't rent it again, right? So if rent movie dot rented equal to true. If it's already rented, then you can't do anything, you just return. Otherwise, what you do is rent movie, you set the rent movie to true, you set the rent movie dot rented equal to true, and also like we discussed, we should increase the version as well, rent movie dot version plus plus, and we have to add this entry in our rented movies priority queue so that when we call the report, we can just return it. So now while adding it, we should create a new copy and then add it. So rent movies dot add new movie. In the new movie, we can get the shop from this, and movie is also given. The price, we can get it from this rent movie price, and is rented will be true because we are renting it, and the version will be, we can get it from the rent movie dot version, and it's a void method, so we just don't need to return anything. We just need to update that we have rented this entry. Now coming to the drop, for drop as well, we can get the movie from shop and movie ID. After getting the movie, let's say just drop movie. For dropping also, like we discussed, we have to update the version to true, and since we are dropping it, drop movie dot rented will be false. This indicates that we have dropped it. Since we made it false, so while we do the search method, we can see that the rented is false, so it is available in the search method. Otherwise, if we don't make it as false, so that entry will be skipped. Now let's finally move on to the report method. So its return type is a 2D list. List answer, let's say report new array list. And Similarly, we are popping the elements. So let's take a temporary, where is it? Let's take a temporary list for this as well. And again, we need the top 5 elements. So while report.size is less than 5 and the priority queue's name is rented movies dot is empty. So while the size is less than 5 and while the rented movies priority queue is not empty, first we get the movie rented movie equal to pq dot remove. So this is the movie from the rented movie, and we also need to get the original movie so that we can compare the version. Original. We can get the original from the shop movie map, and here the shop ID we can get it from rented movie dot shop, and the movie ID we can get it from rented movie dot movie ID. So now we have the rented movie and we also have the original movie. So we just compare if both the versions are same or not. If rented movie dot version equal to this original movie dot version, that means it's a valid entry. So we'll just add it in our answer. First, let's create a list. Entry equal to new. In this, we just need to return the shop ID and the movie ID. We don't need to return the price. So shop and the movie ID. And once we have the entry, we just add it in the report. Also, we have removed it, so we will add it in our temp dot add this rented movie, so that at the end we just restore it back. Where is our list? Rented movies dot add all temp return report. Notice that in the temp we are only adding if the version is valid, but in the search method, even if rented is false, we are adding it in the temp, because in search, even if it's true or the rented is true or rented is false, it has to stay in the priority queue, because at any future point the rented might be false, so that might be valid. But in this report, if the version is not equal to the current version, that means it's a stale entry and we don't need to add it back in our priority queue. So that's why we only add it if the version is matching the original movie dot version. And once we add it, we'll just return the report. Let's test it. Okay. Show movie map dot put. Okay, it's a list, so we have to add. And what now? The priority queue name is rented movies. Yeah, accepted. Let's submit. Yeah, works. Finally, let's go the time and space complexity analysis. So coming to the time complexity, first, while initialization, that means in this movie renting system method, we are iterating on all the entries, and for each entry we are like inserting it in a priority queue, and inserting it elements in the priority queue takes order of log n time, and we are doing it for n. So this method will have time complexity order of n log n. Here the size of n is 3 into 10 power 5. Now let's go to the search method. In the search method, we are just iterating the while loop just 5 times to see all the valid inputs. Like there might be some entries that are not rented, so this while loop might run more than 5 times, but on average it's a constant time. And he says that at most 10 power 5 calls will be made in total. So suppose all the 10 power 5 calls are rented, that means this while loop will run n times, but that's the worst case. So in the best case, it will run constant time. Similarly, we have a rent method. In this, all we are doing is we are putting the new entry in our new hash map. So it will be order of log n. And similarly for the drop as well. For the drop, we are not doing anything. We are just getting the object and we are updating the values. So its time complexity will be constant. And for the report method, it is also similar to the search. Its time complexity in the best case will be order of 1. So total time complexity, we have NlogN plus log n. So NlogN is a dominating factor, so we will just have NlogN. Now coming to the space complexity, all the memory we created is movies hash map, a list of shop movie map, and also priority queue. And in total, they can just contain the entry size. The entries will be 10 power 5. So the space complexity will be 10 power 5, order of n as well. Yeah. I've also written the code in Python. If anyone wants to check it out, I'll add it in the description as well. Hope it helps. And let's catch up in the next video.